Hi, good morning. Thank you for having me, Lead Dev New York. So as Mary said, my name is Maggie Zhou. I currently work as a software engineer on the infrastructure team out west in San Francisco. Before that, I actually lived here in New York City, working for Etsy also as an infrastructure engineer for around 3 years. And along the way, I've learned a lot about building and maintaining systems for internet companies at surprising scale. And one of the things that I keep coming back to is that software systems that you build and maintain can have hidden complexities that make them challenging and modify. These hidden complexities can make software engineers, both super experienced and junior, scared of modifying them, or when you do modify them in urgency or great need, things break in surprising ways. And adding to that complexity is that we rely on so many software systems, both in-house and commercial, to build our products. You have like your actual business logic and your actual product, and that's awesome. But then you also have like this continuous integration system and this monitoring system and this deployment system, and you're on this cloud and that cloud and a monitoring system and maybe another monitoring system and some CDNs and caches, and I can keep going for days, and so can you probably. And modifying any of these systems and many of these systems is like actually required to make forward progress and like build new features and support your customers. But I've seen surprising side effects to simple changes, and I'm sure you can think of some too. One of my favorites was a time of routine provisioning of new machines caused an Apache web server upgrade across the entire fleet of servers across the entire company. Or a time sorting the contents of an array caused a site-wide outage. These were all unknown unknowns. These were surprise complexities of modifying a complicated system. We didn't expect these going in. And so all of this awareness of the consequences of your actions, for me at least, leads to fear of modifying the computer systems. And things do break. And I want to say that this talk isn't actually about incident management or severe and surprising accidents or resilience to systems failure. Liz just gave a great talk about it. Beth Lon is giving a talk about incident management this afternoon that I'm super excited to see. And I think those are all super important topics, and there's a lot of dialogue in existing talks, and actually I love talking about that as well, so find me afterward, we can chat. But what I want to talk about today is what do you do the next day? So like things broke, but you have to go back to work, and you have to sit down on your laptop, and you have to make changes again the very next day. What do you do then? You have to make more changes to more scary software that could break. And we live in this world of this pile of software with complicated and surprising side effects. And so, so you're a technical lead or a manager. How do you ensure that your team is able and comfortable to confidently make the changes that you need to your systems, while ensuring that your product stays available and up for your customers? And how do you get them to the place where you can help them harness their fear of the computer and channel it into like confident engineering? So I like to think about like what can make it less scary. So for me, having a toolkit for making changes to fragile systems in a safer, incremental way has been invaluable in empowering and enabling me to make big underlying changes to shared infrastructure. And this helps me get past my fear of the computer and actually just ship the things that I work on. So today, I'm going to talk through a few of these tools for making incremental changes to computer systems that hopefully you can take back with you to your teams. So at a high level, techniques for confidence. So measure your code, but like how and like why, and also ramp up your work incrementally, but why? And both of these sound great, but they actually have some nuances and gotchas, and so we're going to talk through them in the form of some case studies. When I worked at Etsy, we had an in-house written ORM that was like definitely scary and hard to change. It was one of those pieces of software where if you looked, only a handful of people had ever made modifications to it in a few years. Like you went and get blamed, and you were like, oh no, there's only 2 people listed there. And as a result, we had built systems and systems around modifying it and like avoided modifying it basically at all costs, and we treated it like a black box. And I mean, one of the reasons why it was scary to change is that changing it could potentially impact everything. Data access is bread and butter to an e-commerce site, and if you can't access your database, your site is probably functionally down. But eventually, all black boxes do need to be modified. And back in 2014, I started working on a project to change how our database sharding architecture was laid out so that we could continue to horizontally scale that tier. Unsurprisingly, this required some changes to the ORM. So first of all, I was like, let's instrument the code. So on the left, we have some pseudocode around connecting to the database. Pretend that there's more things there based on how you connect to databases in your life. And here, the thing that I want to point out is that we're actually returning the same thing when we're doing this instrumentation. We're just also adding a metric to see what's happening. And in this case, what I expected my change to be after I made my change was that there would be less connections to the database. So I wanted to instrument it ahead of time and add this metric to see what my baseline was. So this was just around getting a baseline understanding of what the current system's performance was. The second thing was that I was like, let's use feature flags. For those of you who are less familiar, feature flagging is a technique for enabling and disabling features at fine grain, which allows you to enable incremental ramp-ups. Feature flags are frequently used to gate user-visible features or do A/B testing to see which feature actually converts better, or to merge code that isn't ready yet for full launch, but you want to do some testing for some users or do some dogfooding. But for infrastructure changes, or for any work that isn't directly user-facing or you're not launching a new feature, they're actually super useful too, which is counterintuitive because they're called feature flags. And I find that the two big pieces of feature flags that are super useful for infrastructure stuff is incremental ramp-ups, as well as an easy, well-socialized place to ramp your change down and churn it off. Incremental ramp-ups are this incredible opportunity to test your change against a smaller set of real production traffic. If you use the product internally, this is the time in which you can roll it out just to yourself and dogfood it. So here's the old pseudocode that we instrumented just earlier. And this is an example of what it could look like to use something like a feature flag system in order to handle your ramp up. So on the left-hand side, you'll see that we're just checking to see if this feature flag, which we've called db_new, is on. And if it's on, we're going to connect the new way. And if it's off, we're going to connect the old way. And the feature library, which we're calling with feature, handles reading this configuration, which is on the right-hand side, and choosing whether or not we're going to go through which side of the fork. And added benefit, if something goes wrong, I can tell my team, and I can tell my team ahead of time, and I can tell whoever's on call for various stacks, hey, if anything goes wrong and you think it might involve the database, it's totally safe to just churn this config flag off. Make it go from on to 1 to on to 0, or I think a semantic for turning it off should be very easy to socialize. And this gives me the confidence to ramp up my change knowing that my team has my back. Oh, and I just also quickly want to say, the other awesome thing is like most of the time your code is more complicated than the pseudocode, and giving the flag to someone who hasn't read the code is an awesome way of being like, you don't need to look at the code in order to turn off my feature or turn off the thing that I worked on. You can just configure it off without having to understand all of the logic I wrote. So this didn't actually work. This actually triggered out-of-memory errors, or would if we had shipped this. So this is our mental model, and this is what I just walked through. This is what we thought was happening. The ORM calls the feature library, checks to see if it's on or not. We either connect the old way or the new way. But why would this trigger out-of-memory errors? Well, so it turns out that that mental model was wrong. And this is like an example of unknown unknowns. There's a hidden recursive dependency on the ORM inside the feature library. So what's going on here is that it turns out that every call to the shared feature library first checks to see if a user was logged in. If a user is logged in, it checks to see if that user was an admin, which is what we used at Etsy to designate whether or not someone worked at Etsy. If they were an admin, they'd render a set of internally only visible tools and any features that were being dogfooded, but not available to the general public yet. However, this admin user check mostly hit the memcache instance that fronted the database, but for a certain percentage of users that were not in the cache and were a cache miss, it actually went back to the database via the ORM to find the user record and do that check. And we had just modified the code in order so that the ORM used the feature library. So this triggered an out-of-memory error in this recursive loop. I think this is such a great example of a time unknown unknowns in the systems that you build can really bite you. So I actually didn't run into this. My coworker Adam ran into this a few months ago. I was forewarned and forearmed, so I did not do my ramp up that way. When it came time to ramp up my code in this part of the code base, I did something more like this, which was I was actually just ramping it up by percentage of hosts. So I wasn't using the feature library directly. And the reason why I want to point this out, and the reason why I went into this digression about this recursive loop, is that investing time in using a flagging system for your infrastructure rollout is always time well spent. It might not be as simple as using your existing feature system that you might use for experimentation, or your existing experimentation system that you use for conversion testing and so on, but you can do something as simple as like a static configuration of hosts or a static file that you can communicate to the rest of your team, hey, if something goes wrong, just remove that file and there'll be no hosts in it, and then everything will route the old way. I've found that that is always worth the effort. I get a lot of confidence from knowing where the off switch is. I get even more confidence from knowing that my teammates and people who are on call, or like anybody else at the company who might need to turn the thing off, knows where to and how to. So by the time we came around to ramping things up to 100%, it was just another day in the office, and we had made this previously scary change to a black box system pretty boring. But wait, when we ramped up to 100% from 50%, suddenly visible was a performance impact that we hadn't noticed before. And luckily, because we had this gating logic in place, it was super quick and easy to ramp down again, and it minimized user impact. Minimizing user impact by quickly ramping down any performance regressions is an essential technique for deploying infrastructure changes. Sometimes people refer to this as like mean time to recovery, which I think a few speakers today have already talked about. But I just like to think of this as like emphasize quick recovery from downtime over the actual number of outages. That corresponds to the user impact of your change. And I think that feature flag style ramp downs are super helpful for executing this. And as an additional perk, having this ability is super helpful for reducing your fear of making changes. Go ahead and make the change. You know how to undo it. It's quick, and there will be minimal user impact if there's problems. So, and you might already be thinking this, one nuance to this is that things actually get significantly trickier if you're writing a mobile or desktop application. But that doesn't make feature flagging irrelevant. Alison Kapture, who used to work on the desktop client team at Dropbox, wrote a great blog post where she says, if you're writing a mobile or a desktop application, you need server-side feature gating and server-side flags. When you discover a problem and you don't have server-side controls, the resolution might take days or weeks as you push out a new release or submit a new version to the App Store. That's a bad situation to be in. This entire blog post is well worth reading. Alison goes into some really wonderful bugs and debugging stories that are joyful and delightful. So given that, oh, I was going to say one more thing. Given that it's not easy, that doesn't mean that it isn't irrelevant. And it's still, once again, the investment is totally worth it because it enables you to be in control of these bugs. So doing both of these things, ramping up my change incrementally, having instrumentation that I could watch as my change rolled out, these are like engineering practices that help make the system safer as we change these off-use and frequently changed black box systems. But they actually also help me feel more confident in my changes and no longer as scared of changing these systems. Knowing that my team has my back and knowing where to look to understand the performance of my rollout because I took these baseline measurements and I'm looking at them as I roll out is really where the confidence comes from. So I now work at Slack, and at Slack we care a lot about performance. And as a result, I've learned a few new techniques for maintaining the reliability and performance of our product while rolling out these massive underlying infrastructure changes. And at a high level, the big thing I've come to over and over again is that I can build confidence by really understanding my change. And the how is a little tricky. Like, do I stare really hard at the code? For me, it's been easier to learn some new techniques than to just stare really hard at the code in order to understand my changes. And I'll go through these and examples of times I learned these, but at a high level, it's like reducing risk by dog fooding and what I like to think of as measuring my measurements and understanding what's happening in my measurements. So a few months ago, I was rolling out the use of a new database driver at Slack, which would switch how all web traffic at Slack connected and queried to all of our databases. Pretty scary. As part of rolling out my changes, I walked through my mental list of how to mitigate the risk. I was like, okay, feature flags and instrumenting my change, understanding my baseline, great. And in my case, I was also able to use feature flags in order to roll out my change to internal users first for dog fooding, because Slack is a big user of our own product. This reduced the risk of potentially shipping a bug to our customers by being able to test and find it in our own company first. So lucky we did that, because while ramping up my changes to just internal Slack while dog fooding, we ran into an API performance regression, once again, just for our own team, just on one API endpoint. This is a fairly important API endpoint, though, and this happened about the time I started ramping up my changes. So this is the P95 and the P99 throughout November, and I started ramping up around November 20th. And you can, even though there are outliers well before November 20th, there's basically a step function and a seriously visible performance regression here. That graph was generated by being able to segment my metrics by my ramp-up key in order to actually graph it independently of this API endpoint's performance across all teams. Actually looking at this graph for all teams and not just the team that I was ramping up to, the performance regression was lost in the overall noise. So it's super important to be able to segment your metrics by your ramp-up key to catch performance regressions early. And generally, being able to slice and dice your instrumentation into as fine granularity as you're actually rolling out or there are actual differences in your systems enables you to see edge cases early and increases your confidence to go to 100%. Okay, cool. But how did we find out what the actual cause of the performance regression was? So what's going on here? So these are the measurements that we took to find the baseline and after we started ramping up from the data access layer. So this is just like overall my SQL time. I think this graph is connections, but we also looked at queries. And on November 20th, there isn't that significantly much of a difference in performance regression. If you remember the old graph, there was a significant step function that you could see visually with your eyes, and this one doesn't show any significance even while doing analytics, and definitely not with our eyes. So measurements at the data access layer show no performance regressions, but measurements at the API endpoint still showed problems. I spent some time trying to see if it was something else, even though it corresponded with my ramp up very closely. Well, it turns out that the bug was in our instrumentation. We were not starting a timer in the data access metrics as soon as we needed to. So there was a whole swath of time and a whole segment of code that wasn't covered by the timer. So all of that data that we had so carefully examined during our ramp up to find the baseline was actually wrong. And once we fixed the timers and fixed where we were collecting metrics, turns out the performance regression cause was actually really easy to find. It turns out it was an increase in how often we were doing DNS resolution, which was super fixable once we knew what the problem was. I recently read Carlos Buenos' Mature Optimization Handbook, which is a performance engineering primer, which I highly recommend. And he devotes an entire chapter to check your yardsticks. And in this chapter, he says, measurement software is just as likely to have bugs as anything else we write. And we should take more care than usual. A bug in user-facing code results in a bad experience. A bug in measurement code results in bad decisions. Carlos Buenos goes on to describe what we did in this ramp-up case I was talking about as a technique for actually measuring your yardstick, measuring the same thing from different perspectives in different systems. So in our case, we were measuring end-to-end API performance, as well as measuring the system that we were actually changing. If we had only collected the performance measurement from the data access layer or from the system that we were changing, we would never have seen this. And we wouldn't have spotted the regression before it impacted our customers, and customer tickets had been written in being like, hey, I think this is mysteriously slower. What's going on? In Mature Optimization, Carlos Buenos goes over a few more techniques for measuring your yardsticks, and it's well worth reading if you rely on instrumentation to make decisions, which I highly encourage you to do so. So these are the techniques we've gone over for making big infrastructure changes with confidence. Instrument your code, and this comes down to understanding your baseline, checking your yardsticks, making sure that you can segment your metrics into populations that match your ramp-ups and populations that can find edge cases. And ramping up incrementally, and especially make it easy and well understood how to configure your changes off, and get that confidence from knowing that everybody knows how to do that. Personally, mottos like move fast and break things that defined our industry for a while have never inspired me. But I also want to get things done, and I love making these underlying systems changes to support new features and support new products at my job. But it can be so scary. And learning how to make incremental changes to running systems empowered me to actually get things done and ship the things that I build and work on. I hope there are techniques here that you might find useful to take home to your teams and in your own work, making big changes to the software stacks that you own and maintain, and that some of these stories and tools might help empower you and your teams to move faster and with more confidence. Thank you.